My name is Stephanie Saylor, and this is a visual phasing workshop. We will be discussing how to mark recombination points, or the points where we will see changes from DNA given from one grandparent to the DNA given by another grandparent on the same side of the family to one person. I will be showing you how to do Triad Example A today. You can find the Triad examples linked in the description box below. To make things simpler, we will start from the left and work our way to the right. To mark recombination points, we need to mark where each of the one-to-one comparisons have a change in how our two people we compared or our siblings matched each other. Whether it's moving from a no match, indicated by a gray or black bar on the bottom, to a half match, which is a yellow bar on top with a blue on bottom, or a half match, yellow bar on top, blue bar on bottom, to a full match, green bar on top, blue bar on bottom. So let's start looking at the top in the M and N comparison. We see here that the M and N comparison starts with a half identical segment marked by yellow on the top and blue on the bottom. Now if this yellow has some green mixed in with it, that's okay, that happens. It's that blue on the bottom that tells us that we've got a significant amount of yellow. So we're set there. But at this point here, we see a change from that yellow on the top, blue on the bottom, to a solid green bar on the top and a blue bar on the bottom. So we've marked one of our points of change. Now when it comes to points of change, when marking recombination points, we need to know that they always come in pairs, but never in triplicate. So let's look for our second change. When we go down to the N and B comparison, or the comparison of sibling N with sibling B, we see that again they started with a half identical match, that yellow on the top and blue on the bottom. But right here, that blue bar on the bottom stops and it's replaced by this gray-brown bar. So we know there was a change there because that gray bar on the bottom indicates no match. Now to make sure that there's not a problem, we're going to go ahead and check below again in that exact same area. And we see that all throughout that area we have that gray-brown bar on the bottom indicating no match. So we found our 2 points of change that we can use to mark our recombination line, and we verified there is not a third point of change there, so that recombination line is very confident. And we can go ahead and move on looking for our next point in change. On the M and N comparison, we see green on the top and blue on the bottom for quite a ways, which means a fully identical match, or DNA shared by the two siblings on both their chromosome 19s. So let's go down to siblings N and B. And in their comparison, we see that they went from a no match, that grayish brown on the bottom, to a half match, blue on the bottom, yellow on the top. So then we can go ahead and look down below and we see that the same thing has happened below. They went from a no match, marked by that gray-brown on the bottom, to a half match, blue on the bottom, yellow on the top. And when we go and check for a third point of change, we see that there's no change up here. We've got green on the top and blue on the bottom all throughout this area. So we can confidently insert our line of recombination, which means in M, N, or B's comparison, we're going to find a change when we build our map there for one of those siblings. So let's keep going. The next change we see is in N and B's comparison, where they move from a half identical match marked by blue on the bottom and yellowish on the top to this gray-brown on the bottom and gray and gray-brown on the bottom tells us that's a no match. So at this point, we have a half match that transitions to a no match, so point of change. And when we look below, we see a very similar thing. They moved from a half match, indicated by yellow on the top and blue on the bottom, to a no match, that gray-brown on the bottom. When we look above to check to make sure we don't have a third point of change, we see green on the top and blue on the bottom all throughout this area, so we can confidently insert our line of recombination. We finally see the end of this long, fully identical segment we've been working with, where it moves from green on the top and blue on the bottom to yellow on the top and blue on the bottom. When we look below it, the comparison between sibling N and B, see they went from not matching, that gray-brown on the bottom, to a half identical match, yellow on the top, blue on the bottom. When we look to make sure we're not getting any confusion with other recombination points, which will be indicated by that third change, we see that all throughout this area we have a no match, indicated by this gray-brown bottom. So B and M do not share any DNA with each other in this area of chromosome 19. So their parents passed on different DNA to those different siblings. We can go ahead and put that line of recombination in, but before we move to the right, I just want to draw attention to this. Got a little bit of that green on the top sticking out to the right of our line of recombination, and we've got some of this blue sticking out to the left of this line of recombination. And that's okay, that happens all the time and it's completely normal. So long as we don't have any other changes on that third line nearby, which could indicate that we've really got two lines of recombination super close together, and we might be confusing things. And all of our chromosome browser results are lined up well on both ends, then we can go ahead and move on with confidence. On the top, the comparison between siblings M and N, we see that starting at this line of recombination all the way to the end, we have the same thing. We have a half identical segment, yellow on the top, blue on the bottom. So let's move on down to the N and B comparison and take a look. And they do have a point of change. They move from yellow on the top, blue on the bottom, to this gray-brown on the bottom, right here. So they have a point of change. Looking down, we see our second point of change, where they move from this no match area, or area where the siblings do not share DNA, to a half match, yellow on the top, blue on the bottom, where the siblings received DNA from one of their parents that was the same. And if we look above, got that yellow on the top, blue on the bottom, half identical match all through the area, which means we don't have any confounding variables, and we can put that line of recombination in free and clear. The M and N comparison still is half identical, yellow on the top, blue on the bottom, from this combination line to the end of chromosome 19. The N and B comparison, starting at this recombination line, is a no match, so siblings N and siblings B share no DNA on either of their chromosome 19s with each other at the end of chromosome 19. The E and M comparison shows that siblings D and M actually received some of the same DNA. They received the same DNA from one of their parents, which we can tell because of this yellow on the top blue on the bottom. But since we had no changes from this recombination line all the way to the end of the chromosome, that is the end of marking our recombination points for example A. Go to the triad examples and mark recombination points in example B. In the next video, I will review example B with you so that you'll know that you did it correctly.